So, looks like we are in. Hi everybody, welcome to today's session of UPSC Buffet by Gallant IAS. Today we'll be discussing geography questions from 2021. So, we have completed the 2021 polity and economy. From 2021 to 2024, polity and economy has been covered in the previous sessions. Right now, so slowly we'll be moving towards the other portions like geography, environment, ecology, history, and science and tech portions also. So, geography portion, as you all know, since 2021, it has been slowly increasing. The number of questions has been increasing, and the kind of questions we are having are, mostly conceptual and most directly from NCERT only, but they require a conceptual understanding of things. So, while solving these questions, and where there are actually concepts involved, I'll be explaining them, so you can actually get an idea about that, and you can just get an idea and you can prepare based on that also. So that's all about our today's session. So let's get started. So we'll be starting our geography series. Since we won't be having questions mostly separated on the basis of Indian geography and world geography, because the questions are like a maximum of 10 per year. So in these years and recent after 2023, it has got slightly increased. But here in these sessions, I won't be dissecting them between Indian or world geography, because most of the things are connected except for the reverse thing. Other than that, most of the things are connected only. So you don't have to separate it. You don't have to have a mind in a separate understanding. So in geography, I'll be covering both together. Okay. So take the first question. In the case of which one of the following biogeochemical cycles, the weathering of rocks is the main cause of release of nutrient to enter the cycle? I'll be very honest. For some reason, I didn't actually go through these cycles. Okay, that's one thing that is actually I should have done better while actually writing this examination. So that's one thing I'll tell you right off the bat. Sorry, I just have to open the screen brush. Okay. So actually, while writing this examination, I was not very, I didn't go through the carbon cycle, nitrogen cycle, phosphorus cycle, sulfur cycle, which you should be going through. Okay, don't make the mistake I did. But for some reason, the way the question was framed, I could easily arrive at the answer. So based on some normal logic only, nothing out of the box or exceptional. So basic logic was only required to arrive at the answer. So question is like biogeochemical cycles. These are all biogeochemical cycles. Weathering of rocks, meaning the rocks are being weathered, breaking up of rocks into smaller pieces. That's basically weathering. So in a weathering situation, what kind of nutrient will be released? If you think about it, it could release a lot of things, but weathering of rocks is the main source of release of nutrient. So in nitrogen cycle, it's not the main source, because nitrogen is already present in the air and it's been fixed by the rhizobium bacteria and other leguminous plants. Things like that happen because it's a aerial cycle, or the more component, it's a gaseous thing, and so it's a gaseous cycle. Nitrogen is a gaseous cycle, sulfur is a gaseous cycle, and to some extent carbon is also a gaseous cycle in the form of carbon, CO2, etc. But on the other hand, this phosphorus, it's a solid cycle, and the kind of material it releases, or it's not in its gaseous form. We don't see phosphorus gas in its form naturally in nature. Only in trace amounts it might be present, but mostly it will be in its solidified form. So in order to release something in a solid form, it should not be a gas. So that was my only logic. So I could eliminate sulfur and nitrogen right off the bat, and then I thought about it like carbon cycle. Carbon, of course, gaseous phase is involved in that. So I could eliminate that also, and I could arrive at the answer as phosphorus cycle. But you shouldn't be doing that, because questions can get tricky, and with every year the questions are getting more conceptual and sometimes very factual. So don't miss out on these cycles, including water cycle. So the hydrogeological cycle, you should be going through that, and you should be knowing about what is leaching, what is percolation, and things like that. Have an idea about those terminologies, because that really helps you understand the question. Sometimes the question won't be giving an explanation for certain terms which you would be needing. So for example, leaching, weathering, things like that. So this is the only logic you need, something that is solid in nature and that's directly acquired from the rocks itself. That doesn't mean that carbon or sulfur is not released, but it's not the major source of release of this nutrient. Phosphorus is mainly in a solidified form, and it's released by the weathering of rocks. So that's how I arrive at the answer. Make sure to go through all of these cycles. These are very important. That's the only takeaway. Nothing more is needed from this portion. That's it. Moving on, next question. This is a proper mapping geography question from Indian geography. With reference to India's river system, which of the following 4 rivers, 3 of them pour into one of them which joins the Indus direct. So among the following, which one is such a river that joins the Indus direct? The question is a river that joins the Indus directly, and also the other 3 drains into this river, and this river connects to the Indus. Most of you might know, because the Indus river system, Gangetic river system, and Brahmaputra river system is something that we should be studying, but I know it's a bit extensive with all the tributaries and the number of tributaries, and including the left bank, right bank tributaries and their origins. It can get slightly tricky. So I recommend you start off with the Indus river system. It's relatively simple. So in a river system, you should be looking for a few things. Okay, before I say the answer is only factual only. That's why I'm saying few things. That in any river system, you should be looking at few things. First of all, source. Whether it's a glacier or a hill, and that's important. And the source state, that's something else. Okay, that's another thing that is important. Then you should be looking at whether it's left bank and its left and right bank tributaries. I wouldn't give, this is where it gets really complicated, but source state, source glacier, hill, it's relatively easier for you. And don't go by every river that's there in India or whatever you come across. Start with Indus, then Ganga, then Brahmaputra. Okay, then map them based on these. Okay, it's very good if you could keep a map for these and just go through it occasionally, because mapping is something that you can only learn by repeatedly seeing it. Okay, only a visual memory of that thing will help you. So have an idea about that, and don't spend one single day learning everything. This is something that you should be doing every day in bit by bit. That's why it's very difficult. It might seem very easy at first to learn everything, but it's difficult to remember it, and especially if the question is not like this is a slightly easier one. If it's slightly on the trickier side with the chronology or anything that has been asked similar to 2024, it gets really hard. So you should be knowing about that. Then left and right bank tributaries, and also their arrangement from east to west, especially for Gangetic river like Gagra, Gandak, Kosi. How are they arranged from east to west? Their location from east to west, or west to or vice versa. Okay, whatever. One is enough so that you can know the other also. So that's one thing. The answer to this is Satluj. Okay, Satluj is the longest tributary of Indus, and it is the one that actually joins Indus directly. The other 3 drains into Satluj. So that's it. And Chenab is the largest tributary of Indus. So that's the 2 facts that you should be knowing. That's it. Then about the Jhelum river. Meandering of the Jhelum river forms the Ular Lake, that you know. So these are the few facts you should be knowing. I think 2023 a question about Jhelum was asked. Meandering of Jhelum river forms the Ular Lake. Something like that was asked in 2023 as well. So Indus is something that is very important, and don't overcomplicate it. Just take this map alone. This is enough. Map it and learn it, and add these details: source, glacier, source state, things like that. These are the information that's actually needed. You shouldn't be tracing the entire trace of the river. There is no need for that. Just have these information about any river, especially the major rivers. Okay. Moving on, next question. This is again a slightly trickier one. I had absolutely no clue, but few information I had. So that's how I arrived at the answer. I struggled a bit. I did this. I think it was my last question to be marked. So I kind of took a risk with it because I didn't know much about it. Okay. So I'll tell you first how I approached it through logic. Then I'll tell you the facts. First of all, which of the above rise from the eastern Ghats? Okay. So meaning that it drains into Bay of Bengal, and it should preferably be on the eastern side of the subcontinent. So from that, I know Brahmani, because we all hear about Bhitarkanika mangroves and Brahmani, Baitarani. So I know this is in Odisha. So there is a slight chance that okay, Western Ghats passes through Odisha. That is there. So Brahmani could be a a potential candidate for this. Then Nagavalli, maybe Subarnarega. This is where I was able to eliminate one thing, because Subarnarega, I know it originates in Jharkhand and there is no Western Ghats in Jharkhand. So that's one thing that actually helped me eliminate it, because Subarnarega, for some reason, I was able to get along with that, and knowing that Subarnarega was not the Subarnarega originates in Jharkhand, because in few of the questions that I did that year, this river was asked multiple times. This is where actually doing a good test series really comes in handy, because the only thing I knew about this was Subarnarega. So I was able to eliminate that. Eliminating Subarnarega left me with only two options, meaning that Nagavalli is right, and either I have to choose between Brahmani or Vamshadhara. Here also I knew one more thing, that Brahmani is actually a confluence of two other rivers. So there is a good chance that it doesn't necessarily originate from Eastern Ghats. This knowledge comes from the knowledge of Bhitarganika mangroves and Gahirmada sanctuary. These are the things that we often come across in Ramsar sites, olive ridley turtles, things like that. So Brahmani was something that I heard about. Subarnarega was something that I happened to know because of the test series I did. So these two things I was able to eliminate and arrive at the answer. Again, one more thing I ran was, Nagavalli seems like either a Telugu or a Tamil name. Maybe Telugu, Tamil, it could be. So there is a good chance that it could be from Eastern Ghats. So there is a chance, but there is also a chance that it could arise from the Western Ghats also. So that's one more thing I ensure that, okay, if Nagavalli is also there in the option, I should be going it with right away. No need to, have a doubt about that. So I eliminated Brahmani, knowing that it's not originating from Eastern Ghats, and it's a confluence of two rivers, Sankha and Koyal. And then, so one is gone. Then Subarnarega, I know it's not from Eastern Ghats, it's in Jharkhand. Eastern Ghats doesn't go through Jharkhand. So that's eliminated. Then I'll arrive at the answer as 2 and 4. So that's how I arrived at the answer. Ideally, you should be knowing most of the things about these rivers. It's a good practice to actually look through the rivers that are already been asked. Whether or not they are the right answer or not, you should be going through the Brahmani, Nagavalli, Subarnarega, Vamshadhara, because this can be repeated in a different question in a different way. So going through these rivers is actually something you could do after you are done with the major river systems. Okay. If you are looking for the minor rivers, go through the PYQs first and map all those rivers that are being already asked. So a question on Subarnarega could be repeated, Nagavalli, or an option of Nagavalli could be there in any other question. So that's the takeaway. So moving on. Next, this is actually interesting. All you need is a basic understanding about the planetary winds and the temperature and pressure belts of the world. That simple understanding alone is enough to answer this question, and also such an understanding is also very useful, especially in the years of 2023, 2024 and 2025, because I think two questions were asked based on the same concept. So it's a really good practice to learn the planetary winds, because it's a foundation for everything you learn in geography. Everything related to climatology is basically based on these planetary winds. Okay, wind, pressure, planetary wind, that is the temperature and pressure belts of the world. So as you all know, I've just put the diagram here itself so you could know that. In tropical zone, western sections of the ocean are warmer than the eastern section owing to influence of trade winds. First, you need to know what are the tropical zone. Tropical zone is the region between Tropic of Cancer and Tropic of Capricorn. That is 22 degree half north and 22 degree half south. The region between that, not outside it. So the regions inside that, in the tropical zone, what is the dominant wind? They are the two dominant winds are in the northern hemisphere, they are the northeast trade winds, and in the southern hemisphere, southeast trade winds. Southeast trade winds flow from, these both have same direction. That is, the one flow from the east to west. They both flow from east to west, and they join at the equator, and there is a belt of calm, and that is called the intertropical convergence zone. The convergence of two trade winds forms the intertropical convergence zone, some 2 to 3 degrees north and south of the equator, and that region has doldrums. That is a calm area with minimal wind movement. So that's the fact about it. So western sections of the ocean are warmer than eastern sections of the eastern section owing to trade winds. So trade winds location is they blow from east to west, meaning that warm air that is being pushed to the western side. Okay, one thing you should be knowing that western sections of the oceans, forget about all of these land masses here. They are just asking about the oceans only. Okay, so don't complicate it thinking that okay, what if the hot water just sticks here and it doesn't go through there. No, they're just asking about the whole picture. Just forget the land masses here in the northern and southern hemisphere. So the wind is blowing in this direction, meaning that the warm winds, wherever the warm winds are, warm air or like warm waters are there, it will be pushed to the eastern margin. So this is how it works. They will be pushed to the eastern margin only in the tropical region, because what, outside the tropical region the direction of the wind changes and it becomes westerlies. So that's a different story. So this is true. Then in temperate zone we know region outside the tropics, and that is below the Arctic Circle. So the 60° north, these are the regions, 66.5° north to 22.5° north. So that region, that 40° latitude is 44° latitude is where the temperate zone lies. And in the temperate zone, westerlies are the dominant winds. So westerlies, they blow from west to east, meaning that whatever that is in the west will be pushed to the east. So everything will be accumulated in the eastern section, including warm ocean water. So that's exactly that is been given here. So that's the answer. So 1 and 2, 58C. So that's the, then moving on. I'll explain a few things so that learning this planetary winds becomes slightly easy. This is the basic diagram you need to have, and you should be able to understand it and internalize it fully. Okay, this is something you shouldn't be missing out on. This is very useful in mains, and of course if you have got geography optional or planning to take geography optional, this is like a rule book for you. So everything related to climatology is from this diagram. Okay, so you might be knowing about Hartley cell, Ferrel cell, and polar cell. I won't be going into those details, but I'll tell you a few things. So here in the southern hemisphere, the direction of wind is from south. The first in the tropical region, it is from west to east. So they are from east to west. So they are southeast trade winds and northeast trade winds. Always remember, there is an alternating pattern of wind direction. For example, in the northern hemisphere, here are northeast trade winds that flows from east to west. Okay, they are flowing from east to west, and just after that there will be westerlies from west to east. Then again east to west. This is how the pattern is. That's how you study geography. There will be a alternating or repeating pattern, and you need to understand where it starts. Here it starts from east to west, then it will be west to east, then east to west. That's it. And the reasons for these are the pressure belts formed due to the actions of these winds and thermal action of or solar insolation. So let's start with the equator. Why is equator an equatorial low pressure belt? Because equator is getting the maximum insolation, and due to that convection currents happen and the air and water rises, leaving a low pressure region, because the rising of the air creates a low pressure region. So this region becomes the low pressure, equatorial low. So that's it, equatorial low. And then this rising air moves north in either direction. Here moves south in that direction, and it merges with the cold wind from the upper side, and this causes subduction of that wind, and this forms the subtropical high pressure belt, because the rising air from here mixes with the cold air from the temperate region, and the dense air actually subsides, creating a subtropical high pressure zone. So this is a subtropical high pressure zone at around 30 to 35° north and south latitude, and this region is high pressure, meaning that there is very little atmospheric instability. Where there is little atmospheric instability, or where there is atmospheric stability, the conditions are like very stable, meaning that very little wind will be there, and evaporation of the water will be low, as in no more evaporation will be there. A constant high pressure region can cause desertification. That is why we see the major deserts along the subtropical high pressure belts. Not everywhere, but most of the deserts that are found in the world are in the subtropical high pressure regions. For example, Thar Desert, then the Arabian Desert and other places. So that's it. Then the rising air from this, the subsiding air moves in either directions, one towards here and one towards here, and this cold air these two cold airs actually converge here and they rise up. And this rising air forms a solar low pressure belt. Okay, so that's the thing. Then moving on, then the opposite also happens. Here the rising air forms and the rising air mixes with the cold polar air and it subsides, creating a high pressure belt. So these high pressure belts and the alternating high pressure and low pressure belts give rise to the direction of these winds. So in high pressure, winds blow from high pressure to low pressure, that you know, pressure gradient. So here it forms easterlies. So it's normally in this direction, but due to the Coriolis force, there is a curvature to that. And then here it is flowing in this direction. Actually, it should be perpendicular only, but due to the Coriolis effect, it bends slightly towards the east. So here also it should be in this direction, but it flows from here. I hope you understand, because the wind direction is from subtropical high pressure to low pressure. Just remember, high pressure to low pressure, wind flows in that direction, and there is an alternating band of low pressure, high pressure, then low pressure, then high pressure. So that's how things are. Also remember this latitude. Okay, that's all about it. Further details or more easier explanations on things will be done when we take actually the master class of these concepts. So don't worry, we'll figure it out later also, but I'm just giving you an idea how to study this. Okay, if this thing seems very complicated for you, this is what I have already shown you. Have an idea about this also. Moving on, next one. This is slightly a tricky one because similar questions will be asked every year. It's bit tricky to answer if you have no idea about these words, and it's okay to leave them, but you can apply some logic here. Okay, first of all, the few names are given: Didwana, Kuchaman, Sargol and Khatu. From the names of it, we can be sure about one thing, that they are not from South India. So we could eliminate South India from that, because there doesn't sound not at all like a southern name. So either it could be northern or northeastern, and the Didwana name doesn't sound northeastern either. It sounds proper North Indian name. So it could be there, a place in North India maybe. Anyways, it's not in the South India. So that is for sure. So since we will be knowing the Ramsar sites, and 4 Ramsar sites are given, and there is a very little chance that we won't be hearing about Ramsar sites, that to these 4 ones. So we could eliminate that, because I've never heard of, I've studied Ramsar sites because it's a basic thing that you should be studying. It's a non-negotiable thing. So I have never heard about anything in Ramsar sites. Then mangrove areas, saline lakes and glaciers. And Sargol sounds like a name of a glacier, but other than that, Didwana, Kuchman, Katu doesn't sound like a name of glaciers, because we know the name of glaciers. They'll be having Sadopant or names that are similar. In like we would be able to judge the name of a glacier from the name itself. So that is there. No, Siachen, Sadopant Glacier, Gangotri. Those are the kind of names we usually hear. So I also eliminated that also. Then I'm left with mangrove areas and saline lakes. In this, saline lakes is something that I rarely came across in my preparation. Mangrove areas, I've heard about a lot of things, Pichavaram and a lot of, we will be hearing about mangrove areas, but very little have been heard about these saline lakes, and I have heard not much about these lakes either. But I knew one thing, that there are actually multiple saline lakes in Rajasthan. That's one fact I knew. So I was like, okay, mangrove is having a slightly lesser chance, and saline lake is something that I haven't heard about, or I haven't studied saline names of the saline lakes. But one thing I knew was Rajasthan has got a lot of saline lakes, and this particular name kind of rang the bell that it could be a Rajasthani place, or somewhere in the north at least. Not exactly Rajasthan, but somewhere in the north. So there is a good chance that it could be saline lakes. Okay, that was my logic, because I was able to eliminate Ramsar sites and glaciers based on the names. Ramsar sites with fact, glaciers with the name. Mangrove areas, something that we should be knowing, and most of the mangrove areas are in the southern India. Of course, there's in West Bengal and Gujarat also has that, but the names doesn't sound all that of a mangrove area. And again, saline lake is something that we rarely come across, or we usually skip apart. So there's a good chance that it could be that. That was my approach, and I chose the answer as saline lakes, and it came out right only. There could be some logic applied, but I think these were in news and I missed it in the current affair, but it doesn't matter actually. Even if you missed it or even if you skip this question, it's okay. And sometimes people will be coming out and saying that okay, this particular thing was given in their current affair series or somewhere, and don't rearrange your preparation based on that. These are not things. It's okay to miss out on things. Try to apply logic if you really are short on attempts or number of questions you are attempting. Other than that, it's perfectly fine to leave those questions. You will be able to clear it even without knowing these things if your attempts, the number of attempts are enough based on your accuracy level. So moving on, next question. Leaf litter decomposes faster than in any other biome, and as a result, the soil surface is often almost bare. Apart from trees, the vegetation is largely composed of plant forms that reach up into the canopy vicariously. Okay. By climbing the trees or growing as epiphytes rooted on upper branches of trees, this is most likely a description of. Okay. So the question is, they have given a very large description. So almost all the information we need is there, and just take few things into the consideration. Canopy is there, so we need to know which forest has got a thick canopy. So that's one thing we should be knowing. So canopy wise, dry deciduous forest we can eliminate. Okay, they don't have thick canopy. And tropical rainforest, they of course have canopy. Mangrove forest, they doesn't really have a canopy, but they are tightly packed. So I could eliminate deciduous forest right away. Then epiphytes, something that grows on other plants but not as a parasite. Basically climbers which use the plant or tree as a physical support only. So those are epiphytes. So epiphytes are something that we commonly see in tropical rainforest. That is also there. And above all, leaf litter decomposes faster than any other biome. Yeah, decomposition happens very fast. See, in a coniferous forest, decomposition is slow, obviously, because of the low temperature and low microbic, therefore the low microbic activity. So that's not the reason. Mangrove forest, obviously, it's waterlogged. It doesn't necessarily, leaf litter is not going to decompose very fast. So those two options are gone, and with the canopy, I've eliminated that, and I have arrived at the answer. This is a very straightaway thing. We often hear about that, or we read in NCERT that the tropical rainforest has got the least fertile soil because of the low humus content. Because immediate microbic activity actually decomposes whatever the material that are being falling on the ground. So detritivores activities are very high in the tropical rainforest. So that's it. Just read about all of these forests and make an understanding about their their soil structure and the plants, the kind of plants, and with few examples. Learn few examples of coniferous trees, dry deciduous and wet deciduous trees, and mangrove forest. So we know that in Sundarban, Sundari trees are there, and other forms of nematophores. Those are the mangrove trees there. So just learn about that. Okay, mangroves are actually very important. Learn about those mangroves, major mangroves across the country, and learn about the species of mangroves that are there. And terms like these should be noted. That is, epiphyte is not a parasite. Unlike Cascuta, they are not parasites. They just grow on the other plant with using them as a physical support only. Then moving on, next question. Again, a vegetation or a forest kind of question. The vegetation of savanna consists of grassland with scattered small trees, but extensive areas have no trees. The forest development in such areas is generally kept in check by one or more or combination of some of conditions. Which of the following are such conditions? Okay. We obviously have a very good picture of savanna. We have been seeing all sorts of videos from Manual Planet, National Geography, etc. So we know that what savanna looks like. There are dry grassland with occasional trees here and there. So there is some reason as to why it looks like that, or why savanna has that characteristic savanna landscape. So right off the bat, one thing you should be very clear. What kind of place is savannas generally? The savannas of Africa, what kind of a place is that? Is it a place that receives heavy rainfall frequently, or is it a place that is dry? That's the question, or relatively drier. Okay. So that's the one thing you need to have an understanding, because rainfall is asked here, and rainfall is a very crucial factor deciding the kind of the flora and fauna a region has, especially the flora. So we know that why Kerala has such thick dense forest and evergreen tree, because we are getting immense rainfall, and the Western Ghats acts as a rain barrier. Same in Northeast India, we are having evergreen forest because of the continuous rainfall nature of the nature of our region. So that's the thing why we are having a continuous lush green forest all around. So seasonal rainfall is one very big reason that it defines a flora of any region. So seasonal rainfall should be there in the answer. So that makes us eliminate 1 and A and D. So we are left with 4, 5, 2, 3, 4. Okay. 4, 5. For saying that, okay, for it says that, okay, seasonal rainfall and soil properties. Makes sense. Maybe the soil is not fertile enough to, house large trees. Maybe. But here 2 different options are given. This one doesn't have 5. So, meaning that either one of these 2 is right only. So, 2 and 3. Consider that. Fire. Okay. Good chance. A dry place that can get occasionally, that is very prone to wildfire. Very good chance of that. And wildfires can actually destroy the forest entirely. Years worth of trees or grasses would be like gone in few days, matter of days. So there is a good chance that a single fire can actually keep the check of the forest or the savanna grassland for years. A single forest fire is enough for that. So that's possible. Grazing herbivores. Yeah, obviously we have got a lot of herbivores. All sorts of antelopes, deer species are there, and other herbivores are there. They are very omnipotent there, like wildebeest, zebras. So these actually, the number of grazing herbivores are really high in savannas, and that's why we have got apex predators like cheetah, lions in the savannas. So there is ample amount of herbivores there. Very unlike evergreen forest, there is actually quite a lot of herbivores in the savanna region. So that's a possibility. Fire is a very good possibility. So the doubt is between fire and soil properties. It's a genuine doubt only. Okay, we might think that, okay, soil properties actually define the kind of plants that they grow on. So that's there. But imagine in a dry situation, a fire could actually set back growth of plants by even 10 to 20 years. A single fire is enough. So in such a scenario, fire makes makes a better candidate than soil properties if you are given such an option. Okay, you need to think it like that only. Don't think like, okay, soil properties are the ones to go. No, actually fire is a more potential candidate because fire can actually keep the check on everything. Okay, ensuring that trees doesn't grow bigger and only small trees exit, because once during their lifetime, if a big tree gets bigger and it encounters a forest fire, it's gone. Then it have to grow again, and again a forest fire comes. So it ensures that trees doesn't grow bigger. So that's a very good possibility. So I chose fire over soil properties, and thus I arrived at the answer as C. Grazing herbivores is a potential candidate, but I preferred fire over soil properties, and that's why I arrived at the answer C, not the other way around. Okay, this is the logic I had, and there is no particular fact for this matter, I guess. So for example, this same question can be given and the options could be tested also with soil properties included or excluded, things like that, because there is no clear-cut fact as to why or how the savanna is savanna, the kind of landscape they are having. So these kind of questions actually needs your logic to be applied, and your elimination strategies are actually really helpful in these scenarios. Even if the question is about only one, only two, you can eliminate a lot of options and arrive at a 50-50, then choose one. Okay, even if that's where these 50-50 questions are actually good, or only one, only two questions are good, because we will be able to eliminate most of these and arrive at the answer, thinking that one is right and one is wrong, and we might choose only two and it ends up right. So this is why UPSC is slightly moving away from that only one, only two kind of questions, because they tend to reward the people who actually make mistakes. So that's one thing. That's all. Apply your logic and basic understanding about all sorts of forest, especially the savanna, evergreen, deciduous, and coniferous. Okay. Moving on, next one. With reference to water on planet Earth, consider the following statements. The amount of water in the rivers and lakes is more than the amount of groundwater. Okay. The amount of water in polar ice caps and glaciers is more than the amount of groundwater. Okay. First of all, in NCERT, it's very clearly given about the freshwater distribution across various sources. It's very clearly given. But due to the numbers and with the high number of entries in that, we tend to forget few things. So one way I try to remember the whole thing was that it's the distribution of water, on percentage terms, is quite counterintuitive, because rivers have got lesser water than atmospheric water. So that was kind of a awakening moment for me, thinking that, oh, okay, rivers are like the biggest ones out there. You think that, okay, they hold large volume. Of course they hold large volume, but atmospheric water has got higher percentage than that. So that was one thing I had in my mind. Also, another thing was that the kind of things we see, the surface sources like rivers, lakes, etc., they tend to have we think that they have the lot of water, but in reality groundwater is actually the single largest source after the polar ice caps. So that's one counterintuitive fact I try to remember. Even though I don't remember exactly how much percentage is that, I was very sure about groundwater is one of the highest. Okay, and rivers and lakes comes only later only. Even rivers are the amount of water in rivers are actually less than that of lakes. That's also another counterintuitive fact. So amount of water in rivers and lakes is more than the amount of groundwater is wrong. So that's a wrong statement, because it's groundwater only. Then the amount of water in polar ice caps and glaciers is more than the amount of groundwater. Okay, that we know. Like I said, these are the few things we know. Polar ice caps and glaciers hold more water than anything else, and groundwater comes only second to that, and everything else comes below that only. And one more important thing is, even like I said, atmospheric water in the atmosphere is more than that in the rivers. So that's it. So this is right. The reason why I am telling you this counterintuitive fact is that it it allows us to remember things more clearly. Okay, see, this is atmosphere. Atmosphere has got more fresh water than rivers. That kind of took me by surprise when I first came across this fact. So then freshwater lakes has got much more, almost 90 times more than the rivers. So that's another thing. Groundwater is having much more than everybody else. Then ice caps, ocean. Now we can imagine the scale of water that is being held in the ice caps. We might think that, okay, they are just ice caps over a large area, but imagine the scale of water they holds. Okay, rivers is nothing compared to that, ice caps or groundwater for that matter. So yeah, just learn things. If they are counterintuitive, correct it and then remember it. Such questions can be done easily. I don't recommend learning all of these numbers, but if possible, you do that. But the only fact you will be needing is who is having higher than the other. That's it. Having a chronological understanding is enough, but if you can get the numbers, remember the numbers, if you are good with that, do that. I'm not really good with that, so I couldn't do that. So yeah. The black cotton soil of India has been formed due to weathering off. I think this is one of the easiest question in that series, because we know that black cotton soil is in peninsular plateau region, in the Deccan Traps and the flood basaltic region. So we know that the black cotton is primarily formed from not brown forest soil. Absolutely, there are no forest out there. Granite and no. Shale and limestone, no. It's obviously volcanic rock, because what? It's from the Deccan Trap, and Deccan Trap was once a volcano, and it has got a flat basaltic region. So it's volcanic, fissure volcanic lava. That's straightforward, and you know that. Try to learn about the soil types in India, but I don't recommend spending too much time. One question could be asked at most. If you can map those regions, the regions having black cotton soil, region having laterite soil, regions having red soil and forest soil, it would be better. Okay, it won't be highly rewarding. At most a question could be asked, but if you can read about it, then it's fine, and don't go beyond NCERT. Question will be directly asked from NCERT only, so no need to delve deeper into that. Cover your 11th and 12th NCERT thoroughly. That's the basic. Then especially the 11th NCERT, both the physical and human geography part of 11th NCERT, that's the fundamental thing. Then move on to the other NCERTs. What is blue carbon? With carbon, actually there is few things. There is carbon, this is called carbon rainbow. It is blue carbon, red carbon, gray carbon. A lot of things are there. Based on how they are sequestered or how they are released. If they are given a name based on a color. Okay, so that's one thing to remember, because carbon is something that is being sequestered or captured, and something that is emitted based on various anthropogenic and non-anthropogenic sources. So that's there. That's one understanding you need to know. But other than that, this question is fairly straightforward. Blue carbon mean blue, something related to water. Okay. Carbon captured by oceans and coastal system. Makes sense. Carbon sequestered in forest, biomass and agriculture. So maybe this could be something green or something like that because it's forest biomass. Anyways, the naming would be somewhat tied to the usual conventions. So anyways, this wouldn't be right because if it was, it would be green carbon. Carbon contained in petroleum and natural gas. Again, it wouldn't be blue, something like red or gray, something of that sort will be given. Carbon present in the atmosphere. How is that blue in nature? Sky is blue, but that doesn't make it blue. So anything, blue carbon, blue economy, everything has to do with oceans, basically. So that's the answer. Remember, even in this thing is, it's not given here. There is a carbon rainbow, there is a hydrogen rainbow, and you need to know. You actually need to study about that. I've put that material here itself. These are my personal notes. So carbon rainbow based on carbon released and carbon stored. There are actually 8 categories. Okay. First, black carbon is carbon released. Okay. Released by fossil fuels. Gray carbon is carbon released by industrial emissions. Brown carbon released by incomplete combustion of organic matter. Remember, these are all emissions and these are all sequestration. Red carbon, carbon released due to low albedo. Yeah, I think you know that. Ice has got a white color, white texture, and white color and a smooth texture, and this reflects the sunlight. This reflecting the sunlight, reduces the warming effect and the greenhouse gas effect. But if the ice melts and it exposes, the lesser albedo, low albedo, surfaces beneath that, this light rays get absorbed and they will be stored in the lithosphere, and later it will be emitted, causing the proper greenhouse gas emission due to long wave radiation. So that's there. So low albedo can cause carbon emissions. Yeah, that's true, because if albedo is low and carbon that has been reduced because of the insolation, higher insolation, this is called red carbon. Okay, so red carbon, low albedo, brown carbon. Imagine these colors: black, gray, brown, red. These are all emissions, meaning bad things. Okay, these are emissions in a bad way. So these are all negative. Consider them as negative aspect: red, gray, black, and brown. Generally, these colors are given to emissions or something that is having negative connotations, and colors like green, blue, purple, things like that will be given to something that is good in nature. So there is a attribute of good, positive and negative to these colors. Okay. Generally, gray, red, blue, black, black are given for things that are negative in nature, especially in terms of emissions and those kind of things. Keep that in mind, because anything could be asked, like what is green phosphorus or black phosphorus, something like that. Just use this logic and arrive at the answer. Then the carbon that is sequestered. Okay, that's purple. Carbon captured through air or industrial emissions. Okay. Meaning that industrial emissions are actually capturing the emitted carbon, and such carbon that is stored is called purple carbon. Blue carbon, like we said, carbon captured by oceans and sediments. Teal, this is slightly interesting because it's captured by freshwater and wetlands. Okay, so that's something to note. These are not oceans, these are freshwater and wetlands. So if freshwater and wetlands are given, don't go for blue, it's teal. Then green, obviously carbon captured by plants. Then I'll show you the hydrogen rainbow as well. Hydrogen rainbow based on the source of hydrogen production. Okay, so green hydrogen, that is, I think you know how hydrogen is formed. Usually there are two major processes. One is hydrogen extracted from natural gas through steam reformation, methane gas reformation. Then there is another process, is electrolysis of water. Electrolysis of water, passing electricity through water, so it splits hydrogen and oxygen, and we can actually siphon off the hydrogen. But the issue with electrolysis is that we need a constant supply of electrical energy to produce hydrogen. So if we are getting the energy, electrical energy to produce that hydrogen based on electrolysis fully from green or renewable energy sources, then it becomes green hydrogen. That's one of the major missions under green hydrogen mission of central government, because we need to be producing those hydrogen as a fuel from the cleanest and most renewable sources of fuel. Otherwise, the whole point of generating hydrogen as a cleaner fuel doesn't really make sense. So green hydrogen is what we aspire to do. So if we are using surplus renewable energy to generate electricity to conduct electrolysis and thereby get water. But in reality and in practice, this is a bottleneck. The kind of technology and the input output ratio is not very good with green hydrogen programs so far. That is one reason why green hydrogen has got a low share in total hydrogen production, because the setup cost is high and the kind of electricity requirement is high, and even the electricity is sourced from renewable sources. The whole cost is not worth the investment. So we need to be adopting cheaper technologies, cheaper and more efficient technologies for green hydrogen. So there is major researchers are going on that to increase their share in total hydrogen production, because once we are able to get green hydrogen, then we can open up a whole new area of fuel, because hydrogen is a really good fuel. It can directly fuel vehicles, and they could be used in hydrogen fuel cells vehicles with absolutely zero emissions. A lot of applications are there for hydrogen. Then blue hydrogen, that is, like I said, natural gas, steam methane reformation, methane gas reformation. CO2 is a byproduct. That's the issue with this program. That is blue hydrogen. We use natural gas, no electrolysis. Remember that it's steam reformation of natural gas, and CO2 is a byproduct. But that particular CO2 that is being emitted is captured, sequestered. So that's why this becomes blue. And where there are no carbon capture, it is called gray hydrogen, because that's the common process. This carbon capture is also an extensive process. So not all hydrogen production centers will be employing carbon capture, but slowly they are moving on to that also with carbon credits and all. So right now, gray hydrogen is the most common, and followed by blue and then green. But ideally we should be sticking to the green and developing technologies to make it more viable. Black and brown hydrogen from fossil fuels, opposite of green. Basically we are just extracting from fossil fuels, absolutely high emissions, no carbon capture. That's the black and brown name. Okay. Then pink or red or purple hydrogen, electrolysis powered by nuclear energy. Like I said, if electrolysis is powered by renewable energy, it's green. If it's powered by nuclear energy, it's pink, red or purple. Then turquoise, methane pyrolysis. It's not very relevant. It's only a concept right now. Yellow, electrolysis powered by solar. It's a subset of green hydrogen. White, geological hydrogen, found in fracking. You know that fracking means the petroleum that is trapped within the layers of rocks, and we do vertical and horizontal drilling to extract that. That is how shale gas is being removed from the from the ground. Right now there are no strategies for developing white hydrogen, but we can actually rely or leverage on green hydrogen. This can actually reduce our import dependence on other fuels, fossil fuels, and it makes switch to renewable energy much easier, because hydrogen can actually replace the kind of fuels we are already using. So that's it. So I think you all got few insights on this matter. So we'll be continuing this session with 2022 geography and 23 geography for this week, and 24 geography obviously. And the next week we'll be switching to environment and ecology. So stick to our schedule and learn a thing or two, and try to think the way I deal with these questions. So you can develop an insight on that, and those logic will be helpful in actually solving those questions. Don't overthink. If you are having your own strategy, I don't recommend you entirely, if you're having a strategy that is entirely different from what I am saying, I'm not recommending you to follow mine. If you think parts of this are relevant for you, adopt it. And if you don't have a strategy, go for it, follow whatever I say, and I am sure that you won't regret that. Okay, so that's all for today, and see you soon.